Good morning, everyone. Today, we are going to continue our lesson in groundwater, which is lesson 4, groundwater storage. In previous videos uploaded, my group mates already discussed the definition, background, and the types of groundwater. Groundwater storage is the difference between recharge and discharge over the time frames that these processes occur, ranging from days to thousands of years. Wondering what's down there when you are walking on the ground? There's a whole lot of water beneath your feet. The ground stores huge amounts of water and exists to some degree no matter where on earth you are. Lucky for people, in many places, the water exists in quantities and at depths that wells can be drilled into the water, bearing aquifers and withdrawn to serve the many needs people have. Large amounts of water are stored in the ground. The water is still moving, possibly very slowly, and it is still part of water cycle. I have here the basic visualization of groundwater. As you can see in this figure, most of the water in the ground comes from precipitation that infiltrates downward from the land surface. Yung portion na to, which is the upper layer of the soil, ay tinatawag na unsaturated zone, where water is present in varying amounts that change over time, but does not saturate the soil. Below this layer is the saturated zone, where all of the pores, cracks, and spaces between rock particles are saturated with water. The term groundwater is used to describe this area. Another for groundwater, Another term for groundwater is aquifer, although this term is usually used to describe water-bearing formations capable of yielding enough water to supply people's uses. Aquifers are a huge storehouse of Earth's water, and people all over the world depend on groundwater in their daily lives. While the top of the surface where groundwater occurs is called the water table. In the diagram, you can see how the ground below the water table is saturated with water, which is yung tinatawag na saturated zone. Aquifers are replenished by the seepage of precipitation that falls on the land, but there are many geologic, meteorologic, topographic, and human factors that determine the extent and rate to which aquifers are filled with water. Rocks have different porosity and permeability characteristic, which means that water does not move around the same way in all rocks. Thus, the characteristics of groundwater recharge vary all over the world. How groundwater storage determined? Researchers use the groundwater budget equation to explain the change in storage. Groundwater storage is determined by examining the amount of water entering the system compared to the amount of water leaving the system. Dito sa figure, we can be able to notice that as a recharge and discharge fluctuate, nagkakaroon ng pagbabago sa groundwater storage. This change can be seen groundwater levels increasing and decreasing. The long-term average, about 10 to 20 years of a natural system, is in a balanced state, which means recharge minus discharge equals to approximately zero on average. So, the natural water balance should be the recharge minus discharge is approximately zero over the long-term average, and the ground budget expressed as the recharge or the input minus discharge or the output is equal to the change in storage as what I have mentioned earlier. So in relatively undisturbed system, yung long-term average recharge and discharge are balanced. So kanina nabanggit natin yung mga factors na pwedeng makaapekto sa pagbabago ng groundwater storage. So today, ang pupukasan natin is what is the impact of humans on the water balance. When the natural system interrupted by human activities, it can alter the groundwater storage. The addition of pumping water for domestic, commercial, industrial uses adds a new variable to the groundwater to balance equation. The addition of well pumping from aquifer disturbs the water balance. So this addition of pumping increases the amount of water being extracted from aquifer, which generally increase the output of water from the aquifer. So we have here the formula: recharge input minus discharge minus pumping is equals to change in temperature. So this addition of human activity on aquifer requires the system to adjust and find a new revised balance. However, for groundwater system to remain sustainable, the change in storage must not continuously decrease. So, ibig sabihin, yung new balance must be achieved balancing groundwater inputs and outputs. Kaya ang new water balance equation with pumping written for long-term average ay recharge minus discharge minus pumping is approximately 0. So na yung magiging new water balance with pumping. This new balance occurs when pumping remains smaller than recharge and there is a reduction in the amount of natural discharge. Pumping can affect the level of the water table. In aquifer, the soil and rock is saturated with water. If the aquifer is shallow enough and permeable enough to allow water to move through it at a rapid enough rate, then people can drill wells into it and withdraw water. So the level of water table can naturally change over time due to changes in weather cycles and precipitation patterns, stream flow and geological changes, and even human-induced changes such as the increase in impervious surface such as roads and paved areas on the landscape. The pumping of wells can have a great deal of influence on water levels below ground, especially in the vicinity of the well, as this diagram shows. Therefore, excessive pumping can lower the water table so much that the wells no longer supply water, they can go dry. What happens if pumping exceeds discharge? As water is pumped from an aquifer, there is a great amount of water extracted from groundwater storage. If recharge remains the same, there is a reduction in the amount of water available to discharge into the natural environment. Hence, it is important that the rate of pumping remains smaller than the amount of recharge to the system. Looking on the figure, if pumping and natural discharge exceed the discharge rate of the aquifer, there will be a decrease in the groundwater storage. A slight decrease in storage will not necessarily impact the aquifer negatively, especially if it is a short term. However, if there is a continuous reduction of stored water in the aquifer, it could have an impact on humans, which is it would be go dry. And the natural ecosystem, syempre, magkakaroon ng decrease sa base flow to streams. Therefore, pumping must remain less than the recharge over the long term in order to be sustainable. Groundwater and global water distribution. So I have here the pie chart, and we have here where is Earth's water. So as this chart shows, even though the amount of water locked up in groundwater is a small percentage of all of the Earth's water, it represents a large percentage of total fresh water on Earth. This pie chart shows that about 1.7% of all of the Earth's water is groundwater, and about 30.1% of fresh water on Earth occurs as groundwater. As the bar chart shows, about 5,614,000 cubic miles or 23,400,000 cubic kilometers of groundwater exist on Earth. It is about 54% is saline, with remaining 2,250,000 2,526,000 miles per cube, and that is about 46% being freshwater. Water in aquifers below the oceans is generally saline, while the water below the land surface, where fresh water, which fell as precipitation infiltrates into the ground, is generally fresh water. So there is a stable transition zone that separates saline water and fresh water below ground. Um, it is fortunate though for us na yung relative shallow aquifers that people tap with wells contain fresh water. Since if we try to irrigate cornfields with saline water, it is suspect that stalks would refuse to grow. And we have the one estimate of global water distribution. We have water source, water volume in cubic miles, water volume in cubic kilometers, percent of total water, percent of total water. So ito yung binanggit ko dun kanina na yung about dun sa pinag-explain ko about sa pie chart, and ito yung nilalaman ng bar chart which is yung sa fresh groundwater, yung water volume in cubic miles is about 2,526,000. Sa cubic kilometers is equivalent sa 10,530,000, which is in percent of the total water is 0.8%, and percent of total fresh water is 30.1%. So following we have groundwater, which has 5,614,000, and the water volume in cubic kilometers is 23,400,000, and yung total water percent is 1.7%, and yung percent of total fresh water is none. And then we have total global water, which is 332,500,000 water volume in cubic miles, and in cubic kilometers 1,386,000,000, and none yung percent of total water, also the total fresh water. So I hope okay yung naintindihan yung lesson 4. So without further ado, papatuloy ko na yung lesson 5. I-discuss ko na yung lesson 5. So now let us proceed to lesson 5, groundwater movement. Before that, groundwater movement. So the water cycle moves water through the environment. As water falls to the ground as rain or snow, it can run off into streams, lakes, rivers, or bays. So sa figure, the water will evaporate from surface of water. Water that evaporates can later condense through the process of condensation and forming clouds that can cause rain or snow. And the groundwater and surface water are interconnected. When the water table, as you can see in the figure, rises above the groundwater discharges to the surface and becomes surface water. Also, when the water table drops, surface water can discharge the groundwater. The water table is the top of the groundwater. So it is the boundary between the saturated zone below the water table and the unsaturated zone above the water table. The water table rises and falls according to the time of year and how much rain or snow we get. Groundwater is recharged from precipitation, either rain or snow melt that seeps in the ground. So kanina nabanggit natin yung recharge and discharge sa groundwater. So to further discuss what is groundwater recharge and discharge, I have here the figure of both, how they differ in terms of their movement. So groundwater recharge, rainfall and snow melt can run off into streams or soak in the ground. The process of water soaking into the ground to become groundwater is known as groundwater recharge. The area on the surface where water soaks in is called the recharge area. So groundwater discharge flows underground until it reaches a discharge zone, an area where the water is above the land surface. Springs are clearly visible discharge zones. Less obvious is the groundwater seeping into the wetlands or contributing to stream flows. So their flow rates, groundwater moves very slowly from recharge areas to discharge zones. Flow rates in aquifers are commonly measured in feet per day. It may take years, decades, or even centuries for water flow through some aquifer. Groundwater is in constant motion, although the rate at which it moves is generally slower than it would move in a stream because it must pass through the intricate passageways between free space in the rock. First, the groundwater moves downward due to the pull of gravity, but it can also move upward because it will flow from higher pressure areas to lower pressure areas, as can be seen by a simple experiment illustrated. So we have the U-shaped tube filled with water subjected to pressure. So imagine that figure. We have the U-shaped tube filled with water. So if we put pressure on one side of the tube, the water level on the other side rises. Thus, the water moves from higher pressure zones to lower pressure zones. The same things happen beneath the surface of the earth, where pag tayo ng pressure is higher beneath the hills and the lower beneath the valleys. So I have here figure groundwater flows underground at different rates. So some of the precipitation that falls onto the land infiltrates into the ground to become groundwater. So dun pa lang sa mga naunang slides sa lesson 4, so there is also an involvement of precipitation that falls into the land, infiltration into the ground to become groundwater. So if the water meets the water table, which is the below which the soil is saturated, it can move both vertically and horizontally. So yung water doon mag-move downward can also met more dense and water resistant non-porous rock and soil, which causes it to flow in a more horizontal fashion. So generally towards streams, the oceans, or deeper into the grounds. So if nangyari yun, yung groundwater wants to be a member in a good standing of the water cycle, then it can't be totally static and stay where it is. So sa figure, as you can see in the figure, the direction and the speed of groundwater movement is determined by the various characteristics of aquifers and confining layers of subsurface rocks, which is yun yung water has a difficult time penetrating in the ground. So, yung water, mag-move siya below ground depends on permeability and on porosity of the subsurface rocks. So yun na, water moving below ground depends on the permeability, which means ibig sabihin ng permeability, how easy or difficult it is for water to move. So I have here the figure. So in the figure of permeability, a thin layer of water will always be attracted to mineral grains due to the unsatisfied ionic charge on the surface. So it is called the force of molecular attraction. If the size of interconnection is not as large as the zone of molecular attraction, the water can't move. Thus, yung coarse-grained rocks are usually more permeable than the fine-grained rocks. And yung sands are more permeable than clays. So, ayan, may mga araw na din siya. Water attract to grains by the force and water free to move through pore spaces. So, next we have the porosity, the amount of open space in the materials of the subsurface rocks. So here I have four figures. So first we have the well-rounded coarse-grained sediments. So sa well-rounded coarse-grained sediments, usually may siya, higher porosity than the fine-grained sediment. So bakit yun? Bakit may higher porosity siya? So dahil yun sa yung grains niya do not fit together well. So meaning to say, magkakaroon siya ng mga space which is dun dadaan yung na-absorb na water which is continuously, walang masyadong trap. And then next, we have the poorly sorted sediments. So napapansin nyo sa figure, nagkakaroon na siya ng yung parang nag-compact na sila. So nagkakaroon na lang siya ng mga maliliit na spaces which can affect the porosity of a material to enter on the subsurface rocks. That's why yung poorly sorted sediments usually have the lower porosity because the fine grains fragments tend to fill in the open space. And then we have the cements tend to fill in the pore space. So yung cements tend to fill in the pore space, highly cemented sedimentary rocks have lower porosity. So as I have mentioned earlier, yung arrangement or yung ng space ay lumiliit na. So that means that they have the lower porosity. And next we have the igneous and metamorphic rocks. So napapansin nyo sa figure, parang wala ng space. So in igneous and metamorphic rocks, porosity is usually low because the minerals tend to be intergrown, leaving little free space. So yun na nga. So it is highly fractured igneous and metamorphic rocks, however, could have a high porosity. So therefore, based sa if the rock has characteristics that allow water to move relatively freely through it, then groundwater can move significant distances in a number of days. So but groundwater can also sink into deep aquifers where it takes thousands of years to move back into the environment, or even go into the deep groundwater storage where it might stay for much longer period. We have the movement in the zone of erosion. So before that, ano nga ba yung tinatawag na zone of erosion? So upon searching the definition, the zone of erosion is a layer of earth where the pores and cracks are filled with air and water. So ito daw yung sub-earthen region na nag-exist between the earth's surface and water table. So kung napapansin niyo dun sa mga figure na binigay ko, mapapansin nyo dun, may mga, yung sinasabi na zone of erosion is yung mga sub-earthen region between earth's surface and water table. So this zone mainly comprises porous soil and rock. The pores in this layer are usually partially filled with water, while rest of them are filled with air. Thus, in this layer, air and water are able to interact with each other, leading to erosion of water. The main source of water in this zone is the rainwater that has percolated through the layer of soil above, in a process known as infiltration. So, in some cases, sabi daw doon, yung water from the water table is also able to rise into the erosion zone in a process known as capillarity. So, pag sinabing capillarity, yun yung resulta from the capillary action of the erosion layer, kung saan yung capillarity action, yung water is able to climb against gravity from a wet particle to a dry one. So in the zone of erosion, where water rises and is held against gravity, tinatawag ito na vadose zone. And yung tubig doon ay tinatawag na, of course, vadose water. So rainwater soaks into the soil where some of it is evaporated. Some of it adheres to grains in the soil by molecular attractions, some absorbed by plants' roots, and some seeps down into the saturated zone. So during long periods without rain, the zone of the erosion may remain dry. So yun yung kung paano nag-move yung movement ng zone of erosion. So involved siya sa involved siya sa rainwater and this interaction rainwater which is soaked dun sa soil where some of it is evaporated. Next, we have the movement in the saturated zone. So I would like to further discuss about the saturated zone, though I already mentioned it in a previous slides. I want it to elaborate more because kanina hindi ko masyadong in-explain ko lang dun sa figure kung saan siya nakalugar yung saturated zone wherein andun na yung tinatawag na groundwater dun sa past na figure na napakita ko dun sa mga nakaraang slide. So yung zone of saturation or the saturated zone is a layer of permeable rock in which the cracks and pores are completely filled with water. So that's why dun sa figure, andun na yung saturated zone, yun yung almost sinasabing groundwater na. Andun na yung naka-store yung groundwater. So as the rainwater keeps penetrating the soil under the influence of gravity through the pores of erosion layer, it finally reaches the impermeable layer deep below the Earth's surface. So the composition of this layer is such that further penetration is restricted and water is effectively trapped inside the pores of the rocks present there. So sabi daw, as more and more na water percolates down from the erosion layer to the permeable layer over a period of time, the accumulated water saturates all the pores up to a certain height above the impermeable layer, forming a new zone. Tapos yung zone na yun, where all the pores are completely filled with water, yun na yung tinatawag na zone of saturation or the saturated zone. In saturated zone below the water table, water percolates through the interconnected pore spaces, moving downward by the forces of gravity and upward towards zone of lower pressure, where the water table intersects the surface, such as at its surface stream, lake, or swamp. The groundwater returns to the surface. So that's end my discussion our discussion. Thank you for watching, and I hope I give you all the information which you can probably understand what is groundwater storage and how groundwater move. And that's all for today. Have a great day ahead. Thank you.